So I'm going to wing it a little bit today because that's what I like to do, mostly because I run out of time. Have more time to prepare for things and it gets away from me. But this is our About Piedmont slide. If you've seen me present before, you've seen this slide. It's probably updated since you last seen it. We are now 11 hospitals. Piedmont has grown enormously since I joined. I think when I first joined Piedmont, I believe we were 4 hospitals. So at 11, that's quite a bit. And I spend a significant amount of my time just trying to scale what we've built to begin with. So we've had Tableau in-house for about 8 to 9 years, I guess at this point. I was the first licensed owner for Tableau and thought it was the most amazing thing in the world. Really helped streamline my job because I was doing everything in Excel and pulling things down into from databases and CSV files and then building charts and putting them in PowerPoint presentations. I'm sure many of you guys have felt that pain and maybe discovered Tableau, and maybe it was as life-changing for you as it was for me. I certainly did not intend to kind of move down this career path. So last year, I think, this is probably more now since these stats, I think, were before we'd integrated some of our latest hospitals. But 2 million patients a year is what we're looking at that come through our doors. All right, so a big part of what excites me about working in healthcare is just what we're doing and the fact that it can have an impact on the patient's lives that come through our doors. We want to have a positive impact on every patient that walks through. And one of the things you don't want to do when a patient walks through your door is cause them any further harm. So Piedmont has this very audacious goal of getting to 0 harm across a variety of different metrics. So this is kind of blurred, but each one of those rows is an individual metric that we're tracking related to harm for patients. This was our fiscal year 17 end. So this was last year. And then we had 8 metrics that were showing 0 harm for an entire year, which is an amazing feat. So things like CAUTI and CLABSI, so those are central line infections or urinary infections that you get from catheters and things like that that you picked up while you were in the hospital. So that's a really, really positive thing that happened in fiscal year 2017. In 2018, we increased that number to 10. At the top line, you see these A ratings. These are leapfrog ratings that are actually public ratings. And a few years ago, Piedmont did not have such good ratings on a few of our hospitals, which is hard to manage because that data lags by a year or more. Actually, no, it's like maybe 3 years lag. So it's hard to move the dial on that quickly. But what we did is built some dashboards around monitoring a lot of these areas, and we kind of have really advanced notices. What are our ratings going to be year to year? And so you can see across the board for the hospitals that are actually integrated at this point, we have A pluses for all but one, which has an A rating. And these are our kind of harm metrics that we're looking at primarily. So C. diff, SSI colon, CAUTI, and MRSA. You can see our progress towards getting towards 0 harm across the entire system. 48% reduction in C. diff, 33% reduction in SSI colon. CAUTI is down 67%, and MRSA 38% reduction. So we had an uptick of 1 case in FY18, but the rest of them are continuing to move in the right direction. All right, so that kind of leads into where we are today, and one of the biggest things that we're working on and I'm pushing for is a metric framework that we're building. So this is going to be a comprehensive place to plug metrics, no matter what they are. If they're rev cycle, if they're quality related, if they're patient satisfaction related, all the things that are really important to Piedmont from a balanced scorecard standpoint that we want to move the dial on will be here, as well as more minor kind of departmental things will land here. So I think I planned to put this in one by one, but apparently they're all on the screen at one time. So these are the benefits. So we want that single portal, as I mentioned, for all those metrics. We want to have people browsing through hundreds of dashboards, and we have 10,000 different views on our Tableau server right now. So there's quite a bit of content out there, and finding the information you need can be a challenge. So being able to consolidate all this stuff so that you don't have to go to maybe 10 dashboards to get everything relevant to you, you can just go one-stop shop to this place where all your metrics exist, and view them in a variety of different ways. We create scalability through our Exasol platform. If you're not familiar with Exasol, Exasol is a analytics database. It is a massively parallel processing in-memory system. So that means it's really fast. And as Piedmont grows and we add more hospitals, because it doesn't seem like there's going to be an end to that anytime soon, we just add more servers to this cluster of database servers, and they all have a part of the information that they know, and they all come back together with the answer. It works a lot like Google if you were to go and search for anything on that platform. There's no one single server that knows all of the internet. So we also want to create this templated approach to our SQL development. So when we build these metrics, there's just a single SQL template that you fill out, and all you're doing is plugging the new information in. What makes a numerator, what makes a denominator. I'll pull this up in a little bit so you guys can look at it. We also want to have these standard visuals, so I don't want actually to have new Tableau development every time we do this. We have hundreds and hundreds of these metrics, and I don't want to have to build a new dashboard for every single one of them. We can certainly build deeper dive versions of these dashboards, but more often than not, people just want to know, how am I doing on this metric, trended by day, week, month, and all together with the rest of the things that I care about. Also want to have the ability to actually get to the record level details. And this is a big deal with metrics, and where I think a lot of metric frameworks kind of fall down. They tend to be very highly summarized, and they have to be because they're built on data sets that may be billions of records tall. Really hard to process. So actually being able to tell somebody what's in your numerator and what's in your denominator is actually a really difficult thing to pull off, which we've managed to do with the combination of the Tableau and Exasol. Right, and we also want to give the ability to drill into the source application. So you'll see this in the demo that I'll give. So Epic is our electronic healthcare record system. It's the primary application for any healthcare system. So you don't want to pull people out of their workflow. So if they're going to be sitting in Epic doing their thing day in and day out, you don't want to have them jump out into some web browser or some other tool to go get the information you need. It's nice if they can just do that within their current workflow. And the cool thing with embedding Tableau directly into this is I can drill directly into the patient chart. So I mentioned we can get to the individual record detail. So when I see that there's an order for an epidural, and I want to check to see is this actually accurately representing that data, I can see that record, I can click on it and say go to the patient's chart, and it pulls up the chart, and I can review that and see if all the data actually reconciles. And it gives a huge amount of confidence in the data when you can do that. When you can't do that and your metrics are behind all these summaries, people tend to question it unendingly, and that's where you spend most of the hours of your day. Okay, drill to Tableau. Okay, yeah, and if there are those additional Tableau dashboards out there that have that deeper dive, 30-minute analysis, then you can link to that from the metric framework as well. And the last thing is around flexible targets. So you can display targets in there, and the cool thing that we've done with this is I can set a fiscal year target, and if I just want to evenly distribute that, it'll take that, divide it into the number of days, and then say, okay, here's what your daily target looks like, here's what it looks like for the week, et cetera. And just automatically scale things. All right, our next steps with it is I actually want to build a rules engine behind this whole thing so we can identify trends that are occurring. So if there's a provider that's not performing on several metrics, I'd like to be alerted to that. So we could say if you're not hitting, if you're in the bottom 25th percentile on more than 5 metrics, then maybe email me or something. Tell me what's going on so we know we've got a situation we need to deal with. And then the last thing is take advantage of the new features in 2018.3. There's this thing that I've been asking for since I think 2013, which is have the ability to manipulate sets with dashboard actions. So if you've built actions on dashboards before, you can filter things, you can do URLs, you can highlight. In 2018.3, there's a new one that allows you to update sets. So you can manipulate, without being a desktop user, the values that actually appear. And I'll explain where I tend to use that. All right, so I don't think this thing plays in here, so let me flip over to my browser because it was earlier. this is it in action. I'm going to attempt to describe it as we go. This is kind of a card view of the metrics, and when you mouse over, you can see a trend. Right now it's looking at data by month. You can see the target color showing up, green, yellow, red. Anything that doesn't have a target is gray. It actually shows you those targets in the drill downs. Here I'm flipping back and looking at prior month. So by default, it's always going to show current period, but you can slide that little slider back and say, always show me last month, or I can kind of go back in time, and it'll manipulate that for you. You can look at things by categories, so rev cycle metrics, or pick individual metrics if you want. You also have the ability to change the scale, so instead of looking at things by month, I'm flipping over to fiscal year now. So it's recalculating, and we should get a fiscal year number. And if you'll notice, all these numbers are kind of different. This is the cool thing in here. So that's in scale to millions. I've got percentages in here. Some have dollar signs in there. Tableau doesn't do that, unfortunately. So we do that at the database layer, and I can show you that script in a minute. This is actually showing how you can scale the number of columns. This is one of the things I'm going to do later, is actually show in the extensions capabilities that Tableau has, how you can do that automatically. There are drill down links in here. Clicking this link shows how you can get to a real-time report directly in Epic. So this is some of the embedded capabilities. This is drilling down into some of the summary level detail. So behind this epidural metric, I'm now going to add department level detail to this. Now I can see individual departments. I can mouse over that department. It'll give me a trend line for the department now. And then it has drill down links so I can get to the actual record level detail. So epidurals are based on orders, and so each one of those is an individual order ID. And then I click View Chart, and now I'm jumped directly into the patient chart, and I can see the epidural order and validate that it's correct. It's also going to show that if I didn't think something was correct, I can actually get to the logic behind this. So this is the SQL code that we're writing behind each one of these metrics. This strips out a lot of the comments, so it's not enormous in the template that I'll show you guys in a little bit. Let's see the actual comment, so you have to fill it out. This is a secondary view here, and this is showing information in a data grid. So instead of seeing those individual cards that are only showing you current period and last period training information, it shows you, here are the last 10 months is what we're looking at, and I can view every metric in our portfolio. You can mouse over a metric, and it shows you how we actually compare against other facilities within our hospital groups. And then I can change the scale again. Now it's looking at information by quarter, switching back to month. And then this one shows information custom to me. So I assigned a department to myself, and this is a data quality metric that we have about whether we're documenting who the patient's employer is. And I'll pull that up in the live version so you can see that a little bit better. But I thought it was easier to actually just record that video and step through it, because I did cut out a few of the load time things so it runs a little bit better. And I'm actually presenting this at Tableau conference and wanted to leave some out of technical difficulties as I could. So let me flip over to this, and I have a gigantic fake data thing over here because this is fake at this point. What I've done is applied a random number to the actual data in our data sets. I don't think any of this is real Piedmont data. So if you see, our accidental puncture rate is 78%. That's made up. So big disclaimer, if you're going to take any pictures of that, make sure fake data shows up. So this is the card view. And this actually has the extension in here. So let me show you how this piece works. So this is the extension actually embedded into a dashboard. To get an extension in, you simply drag and drop this in here. It'll ask you, to pull something off the gallery. I highly advise you not to do that. And the reason I advise you not to do that is because you have serious risk of leaking your enterprise data to some third party that's trying to do something malicious. These extensions can be hosted on the web. They can read data in your dashboards, and they can transmit that data offsite. So for our use of extensions, they will only be allowed internally. We're actually disabling this function when we push out desktop to our end users because I don't trust people to do the right thing. About as much probably as I would trust my dad not to click on those links in his email that he gives. So I don't want to stake my job on people making good results. So I can click My Extensions, and you will find, there will be a T-Rex file, which is an XML file. I'll show you guys in a little bit. It'll load up this web page. You can have it set to where you need to set configurations. So for this one, those configuration options to pick the parameter that I'm trying to update. What is the width of my header columns? And so this is my header column, and it says clinical quality data there. So how wide is that in pixels? And then what's the width of one in my trellis chart? So this is a trellis chart, meaning it'll move things out into columns and then like word wrap onto the next line for the next thing. So I've got this set to show 4 columns right now. If I were to update this parameter here, that says 4, it would change the number of columns that are displayed. So that was cool enough with the current version of Tableau. Prior to 2018-2, the user could just type in a value. I have a smaller screen size. I can't fit this many things on my screen, so they could change that themselves. But with extensions, I can actually detect what's the width of this and figure out, just with a simple calculation, how many columns could I actually display given the real estate space that's on the dashboard. So anyway, you pick the parameter you want to update. It's set to this columns to display, which you see over here to the right. And it uses these 2 values in the calculations. And so when I resize this, you'll see you can't actually fit all those columns anymore, and so it automatically changed its value to 2, because I can fit 2 metrics on there. Or if I continue to move this in so that those 2 don't fit there anymore, it scales to 1. And if I maximize this and maybe show this in presentation mode, should be able to fit 5 metrics on the screen in here. So a pretty cool thing you can do with extensions. Just be careful with actually allowing your users to use them. On the server side, there's better controls. So when things are published to the server, you can actually say at a server level, this is where you can go. You're allowed to actually run code from. On the desktop side, you're fully at the mercy of the end user making good judgment calls. So to actually disable these things, you have to update registry settings. So if your organization doesn't have your computers locked down, you're kind of SOL with that. You probably don't want to upgrade until Tableau does something like this. All right. Any questions about that before I move on?
Well, I started to raise my hand because I wanted to see how you set up the, I know some people are probably familiar with it, but how you set up like the actual automated offset using those 2 parameters.
Yeah, and I actually have a blog post about this. I can show it briefly, but if you really want the details about it, some of the stuff I'm showing today with the extensions and the performance testing I'm going to show in a little bit, I've got a blog post that list out the code, walk you through it, to explain how everything works. Yeah, let me escape out of presentation mode here. And if I were to, let me go to another sheet. If I pull that up, then my fake data thing goes away and people take screenshots. That won't be good. All right, so there should be a trellis columns and trellis rows. So this is the setup of the calculation that actually makes that. The calculations are actually pretty simple. So I'm using rank, but typically you could use index. I had to get fancier with rank because I have so many things on my marks card that rank and index are both table calculations, and I was having trouble getting it to work correctly. So the columns uses the modulus operator. So modulus is a fancy way to say give me the remainder. So rank -1, modulus columns to display. So if you've got 10 columns, it'll say, if I divide by 10, what's my remainder? And so that figures out what column should this be in. And with the rows one, it uses just the integer part. So it divides by columns again, but then says, give me the integer of that number. So what's the whole number? And then the other one's taking the remainder of that. So it's figuring out what row and what column to create. So it's fairly straightforward, just kind of math to figure out positioning of things, and that's what draws all that data. let me go over to the employee card so you can see this a little bit better. Hopefully I'm not disconnected from the database. That was good. Yeah, so when I mouse over that, I can see my trend. So this is custom to me now. And what's going on is that I've got a calculation in here that gets the username. I think the calculation is actually called username. It's a standard Tableau function, and it gets the person authenticated with the operating system. So I've got it's figured out what my network ID is. In the underlying metric data, I've got employee IDs showing up, and it's just using that as a filter, where my ID matches the row or that particular employee ID. Then it returns that data set. So my compliance rate with getting employer documented is 45%. You can see a box and whisker plot on here, and this is where the 2018-3 feature is actually going to come in handy. Because if there's an action going on here that's running a filter in the tooltip that's filtering to my data and showing my trend and doing, it's not including my ID in the employee comparison, because if I do that, I've filtered out everybody else that I'm trying to compare myself to. So it's only passing the metric ID to that second visualization, the box and whisker plot. What 2018-3 will allow me to do is add my ID to a set, and then I can use that in a calculation to color code that dot differently. So I could make my dot red or something else other than gray, maybe make it bigger just based on the fact that my ID will be in the set and nobody else's will be, so to make the comparison easier. But what you can see, we're looking at October's data. It says for month beginning October 10/1. It shows me prior period on the card, which was 49.2%, maybe hard to read from the back of the room, and it gives me, when was this last updated at the very bottom of the card. It also highlights in here, this is actually 3 charts in the tooltip. The header is a chart, then the line chart is a separate chart, and then the box and whisker plot is a separate chart. So 3 different charts are in the tooltip. And the reason I made the header a different chart is so I could put that little arrow over the month that we're looking at. So you remember we can actually go back in time and look at prior months. And so if I was showing June, so 1, 2, 3, 4, 5 months ago, then I would get 49.2% would be displayed there, and I'd want to know what does that correlate to in the line chart. So that little blue arrow that's in there is pointing to the month that you're looking at. So 45% is where I'm at right now, and you can see I'm actually the best in the company. So we really suck at documenting who your employer is. It's actually a big initiative to actually improve that at the moment. So I'm in the outlier section over there. But because I can't color it, you don't see that, but you have to know, all right, 45%, where's 45% on the bar chart? All right, so that's a cool version. I have a provider version of that as well. So providers are kind of different than employees. There's an entirely different field for that. So they have their own custom version. So if a provider comes in there and they've got 50 metrics associated with them, they can kind of see how they're doing on each one of those. All right, and let's go to the drill down. So this is again an epidural metric, and here I'm going to show another extension that we'll be adding. And I guess I'll click the load. So it should be good now. So right now we're set on metric 3, and this is how we're actually able to get to the underlying detail. There's individual views at the database for every single metric that we create. And if you stack all those things on top of each other, which is what we've had to do in the past, and do this gigantic union statement, performance is awful to try to get all of that data. And you don't want to materialize all this stuff because it would literally be billions and billions of records and just not be good. So each metric is stored in its own self-contained view. The problem is with Tableau, you can't actually tell Tableau to swap the data source for you until 2018-2. And so the way this works is there's a select star from in custom SQL when you connect to a data source in our data warehouse, and we plug in a parameter value. So you can actually parameterize your data sources. Let me see if I can pull that up. Data source. And switch this to one detail already. And metric detail is a custom SQL statement. And this is how it works. So select a dot star from metrics, that's the schema, dot, and then in quotes, parameter dot data source, because XSOL is case sensitive on your names for things, so that's why the double quotes are there. And you'll see we have to do a funky way we actually name these views in the database, because when Tableau passes this parameter in, it puts quotes, single quotes around it. So our views are actually named with single quotes on either end to kind of make this work. So to get to the right metric, all I got to do is change the parameter so that it points to the correct view. The view code is in the catalog associated with metrics. So when we build the metric data set, we attach it to the catalog, and the catalog tells me what the view name is. So that's all data driven. I just need to be able to take that value and plug it into the parameter, and that's where extensions come in handy, because when I click on things in the Tableau visualization, I can have JavaScript code recognize that I click something and do something with that data. And so we're on metric 3. This is my data source parameter that I'm controlling. This is the extension off to the right here. It's just a HTML web page. And I can configure this one too. So it's going to read, what are all the parameters that I might want to update. So data source is the one I'm going to update. And then what's the field I'm going to use. So I can find the view name, which is coming from my data set. So I want to write the view name from my data set into the parameter called data source when a user clicks on something. So let's try switching to something. Again, hopefully I'm not disconnected and this doesn't take too long. Let's do inpatient consults. Still cached. So when I click on this, you'll notice that the parameter, if you pay close attention at the bottom, actually just changed. It is no longer metric 3, it is metric 83. That's now the data source. And so when I click the icon that says view underlying data, that data source is now pointed to the correct metric. And it's going to actually query the database again and find the individual records associated with that. There we go. From a developer standpoint, it actually writes a SQL statement for me too. So if I wanted to pull all this data up in the database and do additional troubleshooting, I can just copy and paste this SQL statement into my editor and have access to it that way. Any questions so far?
To view the SQL
Yes.
in that, and we're familiar with running the tool and stopping it with SQL stuff.
Mm-hmm.
How do you get that to display?
So the SQL I pull from the metadata from the XSOL
You're
database.
pulling, okay,
Yeah.
so it's displaying it.
Yeah, and that's actually another thing. Let me go back to the detail here. Okay. So here's where I'd be able to jump directly into the patient's chart or to their account maintenance or patient station, metric logic. I can click any of these links if this is embedded inside of Epic, and it would jump through that place within the application itself. Outside of Epic, they just don't work. But one cool thing that we can do here is if we question something after balancing this up against what's showing up in the healthcare record system, I can say something doesn't look right. This provider wasn't the right provider assigned here, so maybe we need to fix something. So I can click this last one here, which says view metric logic. And then that jumps over the thing I'm disconnected from. And these are all live queries against the data warehouse. These are not extracts. And there's the code. And there's some regular expression stuff in here that's actually stripping all the comments like I mentioned earlier. And I can switch to any other metric and look at that from here as well. But I can trace, what is showing up as a provider, how am I actually doing that provider logic. So in this case, we're using the treatment team table, looks like, for locations. Hospital account location comes from the table called HA, which is the hospital account table, and the field location ID. So we can easily trace where we're pulling all this stuff from just by looking at the SQL code. So this makes validation of a given metric much easier than it has been in the past. All right. Any other questions before I go into the actual code behind us and show you how it's built?
guess that you guys have protocols show that there is something wrong with logic and have to fix that.
Yeah, we
Can't communicate back and forth to the teams.
We use agile development processes, so we have teams that are dedicated to individual areas. So this might be something that's coming out of the hospital quality team. So we work directly with the business owners through that kind of 2-week span of work to try to make whatever corrections are necessary. There's governance built into this because we can flag metrics as being in production or in development or retired. That's actually another thing I can show you. Let me go back to the metric card here and let's pick this one. And there'll be another link in here where I can say view metric or edit metric settings. So this is the actual catalog, and this comes from another custom thing we built called Edit. Edit is an acronym that stands for Exasol Data Input Tool. So it's a way of getting data from a web form directly into the data warehouse so we can use that information in our queries. So this is where the metrics are actually set up. So this is metric ID 84. This is a short name. This is the long name that appears at the bottom of the tooltip. What category does it show up in? So I can make changes here and on the fly, if I go back to that dashboard and query immediately, it's updated. I don't have to wait for any extracts to refresh, which is pretty cool. The other thing we can do is we can switch between Exasol-based metrics, our data warehouse, and Epic-based metrics. Epic has their own metric framework and their set of tables where things are stored. The problem with their stuff is you can't get the details behind it. But if we want to accelerate something and people are just happy with taking whatever Epic definition is, we can say it's an Epic metric and give the Epic metric ID. It'll automatically query the Epic database into Exasol into our metric framework, which is a pretty neat thing as well. Here you see this is where the metric view is defined, whether it is a how are we doing aggregation for numerators and denominators. We have the ability to make really complex logic. We have Net Promoter Score too, which is actually a hard thing to pull off. Kaylin, wherever she is. Kaylin built that one out and involved a lot of kind of special calculations which you can define in this custom numerator and denominator logic. You can define here whether lower is better or not. This actually changes the icons. So if we flip back over to the Tableau dashboard, you can see that sometimes the up arrow is green, like with the ED visits, and sometimes it's red, like with the epidurals. That's because we've flagged that as being, up as either good or bad. The number format all comes from this. So this controls how it's actually displayed. So you saw earlier you have percentages, you have dollar amounts, you have differing numbers of decimal positions. This is all handled with an Excel-like number format. So if you're familiar with formatting numbers in Excel and using this custom number formats, then you can use this as well. It also will scale, so you can do conditional number formats. Excel does this too. You can say if the value is greater than 1,000, then format it with a K and scale it appropriately. It's in millions, you add an M or billions. You can easily scale that because when you roll these metrics up from a daily level, which are small numbers, to a fiscal year numbers, which are really big numbers, you don't want the number to go off the screen. So this handles all that for you. Yes?
But couldn't you also do that in Tableau?
No, Tableau does not have a number format capability.
I thought it was in the format. Oh, you mean like actual calculation?
To vary the format. So if it's a single value field in the database.
Yeah. So you meant in calculation.
Yeah, so this does it on the fly. And so this is a database function that we've written, which I'll flip over to in just a second just to show you what that looks like, which will take the value from Tableau. You can use raw SQL. So if you have a live connection to a database, you can use a function in Tableau called raw SQL and call a database function to do something for you and give you the results back. So that's exactly what we're doing with our format. In fact, I'll show you guys that as well. Go back over here.
Can I ask a real basic question?
Yes.
Why would you just Tableau calculated fields? What was the reason?
What do you mean?
Like the calculation, like you have a metric, why couldn't you create a calculated field in Tableau?
To do the formatting?
No, just for the calculation, whatever you're calculating.
It's going to be,
Whatever metric it is.
yeah, well, each metric is going to be different. So You know, some things will be averages, some things will be medians, some things will not have a numerator denominator like ratio relationship. So they're all going to vary metric to metric.
Right, well, couldn't each one of those be another calculated field?
Yeah, but if you're trying to scale this to thousands of metrics,
So that's,
yeah, you're going to write thousands of calculations. So there's one calculation. The calculations are actually defined in the view or in that web form that you looked at, and then on the fly the database does that correctly. So let's see, the one that does the number format, find that one. Good. Display. Display SDR. Yeah. So here it's using this raw SQL string function because what it's going to get returned is a string version of that number with dollar signs or percentages. And it's calling this function called UDF format value. It's passing into it %1 and %2, which represents these values from your Tableau data set that you're working with. So value 1 is the display value, which comes from what we're calculating as our numerator, denominator, whatever our metric value is. And then the display format comes from that web form that I just showed you. So that tells the database how to actually format it. At the database layer, that is this one. So it's actually Python code. With an XSL, you can use Python. So it just defines the function UDF format value, pass information into it, and then it figures out how to process it. And it can run through all this code super fast. So on the fly, it's calculating all these things, which is really cool. All right. And anything else in here? So the thing that was complex about metrics that I didn't realize really going into this is that if the metric isn't something that just naturally sums up, then you're going to have a hard time storing that data. In Tableau, you can remove blue pills, right, and you can say, oh, that's going to automatically sum up to my correct number. If I had providers in there and it would show me provider level data, if I remove providers, now it's going to show me the data for everything combined. Well, some of the metrics just aren't that simple. I mean, what if the provider's value is an average? And so now I've got, when I roll that up, I've got an average of an average. So this is smart enough to figure out, okay, if it's not a sum-based metric, or I haven't explicitly told it to materialize values of different grains, then it'll automatically generate all of the records that it needs. And so then at the Tableau layer, it says, okay, you've removed provider, so let me look at a different section of this of the data set that I've generated, so I'm not getting averages of averages. And that's all controlled with some of these checkboxes here. So if I have an average-based metric or median or something like that, I'm going to have to say, actually generate daily, weekly, monthly, quarterly values. So truncate the date to the week level or the month level or the year level, and then calculate the value for that, store that in the database, because I can't just remove dimensions to get the right number. Yes.
So based on what I'm understanding, you actually have some values that are stored almost two different ways. Or is it like the raw data is stored one way and it's how you join?
Yeah, they're stored two different ways, and Tableau's sorting that out. It realizes, oh, you've had to materialize all these different granularities for this metric, so I'm going to treat that one differently than I treat the other one. Yep. Okay, and this is our governance piece here, so it's an active metric where it's in development, and then who's approved it and their signature, so that we can only display things that have been certified and gone through governance. All right. So at the database layer, this is how it looks. So we've got the metric schema. You saw that in some of the queries. We've got tables in here, and we've got a script that'll actually populate these tables for us. So it has to summarize this stuff and it processes it in the evening and creates those summary data sets. And then when it needs the detail, it goes to the underlying views that we're used to actually build all this stuff. So metric summary has all that summary level data in it. And then we have our views, and we have one of these for every single metric that we build. So if we have this orders-based metric, I think 3 was epidurals. I'll copy that one. So this is the code set for that. So So this has all the comments in it. I mentioned when you're actually reviewing that in the Tableau dashboard, it strips all the comments out because it's way too much information to display. But for the person developing this, they just have step-by-step instructions. Step 1, do this. Step 2, do this. This part of the data set is what defines what is an individual record. So for this metric, an individual record is an order ID. And it tells me also where can I go to get more information about this. So if I were to query on order ID, I could hit this Use Clinical Order VW table and find more information about that order. And then this is all the stuff that's standard summary levels for it. So there's a date, there's an entity ID, a department ID, provider ID, network login ID for employee-based metrics, and then I have a couple custom levels. So if you're just not satisfied with those summary levels and say you want to summarize by financial class, you could make up whatever you want in those two custom levels. And then below that, you've got how are we doing our numerator denominator. This one's very simple. There is no numerator, there's only a denominator, and it's just 1. So if I find a record, given my where clause condition, then count it. Other things may be more complicated where you've got case statements written in here. For the ones that are going to require lots of aggregation level calculations, then you can use all these field 1, 2, 3, 4 through 10 values. Write custom logic in that web form and it'll calculate that for you. And then these are all the tables you're going to, and then whatever your where clause kind of conditions are. So for every metric you build, you just pull the template, you populate this, you update the metric scheme with it, add that record into the catalog. The next time the script runs, which is daily, it picks up that metric and visualizes it in the tool with no additional Tableau work necessary. And that's pretty much how it works. All right. So the next thing I want to do is talk about how some of this stuff is built with the extensions. But before I move into that, any questions about the metric framework in general? All right. I take it everybody totally got everything I just said. All right, everybody's on board. Moving on. So this is how extensions work. So you have a T-Rex file. So if you go to the Tableau conference and see everybody with these like Tyrannosaurus Rex things going on, that's Tableau something extension X. I guess XML, because it's XML file. So it's the manifest file, and it basically describes, here's some metadata about the extension, its name. The most important thing is where do I go to actually hit the web page behind this extension. So there's a link to that. I'll show you the actual code behind one of them in just a second. So that links to that HTML extension file, the green block below it, which may have CSS code for styling to make it look pretty, and will have JavaScript code, which is the programmatic part that allows it to interface with Tableau. There could be a separate HTML page which you use for configuration. You saw those configuration pages on both of the extensions I had in the Metric Framework workbook. And then it might have its own CSS file for styling and JavaScript code to manage configuring the extension for you. Anything that you actually configure, so if you pick a parameter or a field or whatever it might need to do to know to actually configure your extension, that actually gets written back into the Tableau workbook itself. So if you were to search through the XML data within the TWV file, you'd find the configuration items that were written to it. All right, so quick break here to explain synchronous versus asynchronous programming. Anybody know the difference? Anybody program in the room? These people. So I'm very much a synchronous programming guy, so the asynchronous stuff drives me nuts. I write a lot of stuff in Python to automate several things that we do at Piedmont. And it runs, here's step 1, here's step 2, step 3, step 4. I'm going to run that in order, and if step 1 is held up, I'm going to wait till that happens. Asynchronous programming can totally screw that up, where step 3 and 4 ran before step 2 because step 1 called something and needs to wait on a value to return. So this is important for JavaScript because When you're writing a web application, you're usually making calls to other services, you gotta download some image, and you don't want the whole web page held up and load that image and then this image. You know, it makes these asynchronous calls, so it can do a lot of that stuff in parallel, but it's hard to wrap your head around. And so the reason I'm going into this is because the extensions are actually written in JavaScript, and they are written with asynchronous calls, which can be hard to wrap your head around. So this is the difference when you're writing JavaScript callbacks. Callback is basically it says when I finish, call this other function and do this thing. So these are two different kinds of functions in JavaScript. There's a synchronous function at the top, and then an asynchronous function below that. So the synchronous function is very simple. It's just add one to some variable that you pass and return the result. It's actually going to wait and not do anything else until it can actually return that result. The second one, which is to get a web page, is not going to wait. So it's going to call, so if you call get page, then it'll just move on to the next thing and start doing its own thing while it's still returning the page. So if you needed the results from get page, you're going to have to use that as a callback function. So that's the process response, a big callback kind of arrow. It says once I'm done getting the page, then process my response, and that's another function, and it's going to actually run once that first function completes. So you get into this kind of thing called callback hell. This is a real thing. I didn't even make up that name, although I understand. So this is a verify user function. I pulled this off a web page, which is referenced on the next slide. And it's called callback hell because you have all these kind of nested brackets and parentheses, which you have to remember to close off. And okay, where does this function start? And the next thing to begin. So the way Tableau has kind of gotten around this kind of callback hell, they use what are called promises to escape that. And promises are not, they don't remove the callback functionality, they just make it easier to read. So this is the verify run function rewritten instead of having these 21 lines and all these different nested parentheses that you're trying to keep track of. And if you guys are used to Excel, you know the pain. So this uses what's called a promise, which has a then function. So when the promise is fulfilled, then it's going to run whatever we put into the then function. And so it's a much more succinct and cleaner way to write and understand what's going on. This is a visualization of that. So promise.then, you have an unfulfilled and unrejected. So there are two outcomes of a promise. If you ask for a web page, you either get it or you don't. And so you can get the unfulfilled function that gets called or the unrejected function that gets called. So promise gets created, there's a pending result, there's an event that fires and says, okay, I either gave you the result or you did. All right, so with that background in mind, flip over and show you what the code behind this looks like. And if you're like, I am not following whatsoever at this point, this is all on my blog. So, I mean, pull that up. So my blog is just UGA. I went to the University of Georgia. The dogs. Sad weekend. So UGAMarkJ.blogspot.com. You can see here's the explanation of my trellis auto resize, and it has all the code in here and explanation as to what all this stuff does. Same thing with the next thing I'll show, which is the performance tester. That's on my blog as well. So this is the T-Rex file. Let me actually format this so it looks a little better. So it's super tiny right now. Let me zoom in. So this is the manifest, and it's XML format. Looks like a web page with tags because XML follows that same kind of format. And you can see there's things like a description in here as to what the thing does, who the author is, where you can go to get more information about it. All of this jibber jabber stuff in here is an encoded version of the icon. There's a website you can go to, like base64 encode dot something, where you can drag an image into it and actually just spits out the jibber jabber for you to copy and paste in here. And then it actually, this is the actual icon that shows up on the about page. So no, I didn't write all of that. So that's the key thing, but the main part of this is where do I go to get my extension HTML file? So that file that's referenced here is this one. So this is an HTML file. It adds a bunch of JavaScript packages in here. This is the deal with the fact that Piedmont uses an ancient browser with IE11, and it sucks. So this is the fix the sucky IE11 package. Then you have jQuery, which is to make JavaScript writing easier and more fun to write. Bootstrap stuff is what makes formatting look pretty. It's a package to format buttons and stuff like that, so it doesn't look lame. This is what Tableau has written, which allows you to interface with the actual workbook, the Tableau dashboard. And then this is your code. So this is our extensions code called trellis.js. And there are various little elements within the actual body. This is what you see on the web page. So there's a few things in here that we've given IDs to, and that allows me to reference it in JavaScript code. So I could say JQ width or JQ height, or gram value, and I can easily from my code say write something to that tag that has that ID. That's the whole purpose of putting those IDs in. The JavaScript code looks like this. So this whole function right here, well, first you got the document.ready. So basically, document.ready says once the web page is loaded, then fire this code off. And here you got your extensions async function that gets called. It says, okay, when I finish loading the website, load the extension, add in this configuration thing, add an event listener. So the event listener here is when a setting has changed. So if something changed when the user configured it, then fire a function there. This button testing is something when I was playing around, so that's actually not even needed. But the important thing is here, the JQ update size function gets called. And so we find that one. Here it is. This is what's actually controlling all the resize stuff. The current setting is getting me any settings I've saved in my workbook. So that reads it out of the XML file from the Tableau workbook. That gets my width, my two width things, and what parameter am I trying to update. Those get stored in the current settings and have these attributes like a parameter, header width, column width that I can reference. So I get the width of my window. So that calculates how wide am I. Height isn't really necessary. I just left it in there because I stole the code and didn't bother to delete it. By the way, that's the best way to write code, is just to steal it from somebody else. And then this actually calculates how many of these columns can I fit in here. So this runs this max function in here, which says give me the max between these two numbers, just in case something gets calculated as a negative. It cannot be anything smaller than a 1. It takes the width minus my header width divided by my column width and figures out how wide can I actually, how many of these things can I fit on the screen. So that's where the magic happens. Writes it in this variable called p. Here it's writing back to some of those elements. I remember I showed you the IDs of JQ width, height, and brand value. So this is just writing those values onto the web page so I can actually see what it's doing. And then it says update parameter. So it's called update parameter 2 because I beat my head against the wall trying to get this to work with version 1, which never turned out right. So I created version 2 of these and deleted version 1. That says 2, 2020, you wondered. I'm by no means a coding expert. So if you are a coding expert and you're looking at my stuff here and you're like, this guy sucks, you're correct. So update parameter calls a function from Tableau, says change value asynchronously. You see the then function, so this is why I showed you guys the whole promise thing. It says, once you actually give me the result of this, then I want you to do this other stuff and write that value in. So that's the magic of this one. This was the configuration page, which I won't go into too much, but this is the web page that's displayed, and this is the JavaScript code behind it. This is the part that actually gets all the parameters from the Tableau workbook. And Tableau has all this stuff kind of documented within their API reference guide, so you can kind of learn what functions you need to write in here. But get parameters. Once I've returned my parameters, then for each parameter, it adds it to that drop-down list so that users can actually select it. And at the very bottom, I think there's the close dialog, which says save my parameter values. that I've just written in. All right. Any questions about how extensions work? You got it. They're cool with what they can do, but you definitely need to up your JavaScript game, which is not always fun. Okay. The last thing I want to show you guys. Get back over to my presentation here, make sure I don't skip anything. Yeah. Okay. Automated server performance testing. I've got a web page up over here, and this is another JavaScript application. Helpful to know JavaScript. It uses the JavaScript API from Tableau to load dashboards in and count the number of seconds it took to actually render the thing, and then print those results back out to the web page. And it does this for two of our server environments. So we have a production environment, and then we have a test environment, which we use to test all of our upgrades that we do. And so it writes in a smart time the URL that it tried and how many seconds it took in both production and test environment. Our production environment is running Tableau 10.5. Our test environment is on the 10.2 version. So if I refresh this, you can see, here's the total number of seconds, and I'm looking for areas. Am I concerned about any of this? That my stuff is just not going to load. My users are going to be unhappy that I upgraded them and performance somehow took a dive. I will go ahead and hit the refresh button. We'll see how this goes. The one thing
is on
2.2.
You said 10.
Yeah, sorry. Yeah, 2018.2.2. Yeah. So that dashboard, the IP dashboard, took 16 less seconds to load in production. And then it's already pulled up the visualizations. You can see spinning. That's test. That took 11 seconds, so that's positive. So our first one loaded faster. The one thing to realize about this is that I cannot control Tableau's use of cache in here. So that's what Tableau is doing to make things faster. So instead of having to hit the data source again, it'll cache that data in memory so it loads faster. There's URL parameters that you can use to tell Tableau to ignore cache and rehit the database. But with the JavaScript API, there's no way for me to access that and tell it to do that. You can put the URL parameters in there all day long and they just don't work. So this is hitting cache. All right, so while that runs, I'll flip over to what the code looks like. And this is all on my website as well. This is the web page that we're looking at now. There's really not a lot to it. You see the currently testing. There's a span in here that I've given an ID called test dashboard. Flip back over, you see currently testing. Test dashboard has a URL in it. So it's writing to that from the JavaScript code. And then I've got this div for my results and a div for my Tableau viz. So that's where it's actually throwing the Tableau viz and I'm trying to render it. The results is where I have my table stored. The web page doesn't have a lot in it, so it just dynamically writes from the JavaScript file, which is this one. And there's just a few things that you have to configure with this JavaScript file. You have to configure what are my list of dashboards that I want it to test. And you want to make your server name be server in brackets in all caps, because what the code is going to do is going to find that text in there and swap it out with your actual server names. Your actual server names are stored in this variable called servers. So it's a list. Tableau.piedmonthospital.org is our production environment. Tableau-test is our test environment. If you wanted to test more environments, because you have more, you just add more servers to the array here, and it'll continue to test that, write that out as extra columns. So as many dashboards as I want to test, and let me tell you, this sucks to actually test this, and I don't know, Eric, yeah, Rich tested it. It was fun, wasn't it? I did that for years. So I'd sit there with my stopwatch on my phone, and I click the link and immediately hit the start button, and I'd just read the number of seconds, and I'd type that number into a spreadsheet. And then I go on the test site and run the same thing, and key all in, and it would take forever to do that and have some confidence in it. So basically what I did is I moved up in the organization is I started tasking the people that work for me to do that. That worked for a while. So Rich was helping me out. He did it on a Friday, and he stayed late and knocked it out. And then I just could not get to it on the weekend to pull some log files to see what was going on. So I'm like, crap, I got to do this myself now Monday morning because I could get these results to Tableau and tell them something's not looking right. And so I started doing it again. I'm like, this just sucks. I'm not doing this anymore. So then I just sat down and wrote all this code and generated this web page. And Rich is probably happy now because now he doesn't have to worry about repeating that process or handing that off to someone else and poor sucker down the road. So, yeah, the way it works is very similar to the other one. There's a onload function that occurs somewhere in here. Yeah, here we go. Document.ready, and it calls the performance tester function. That's this one here. And basically, this just runs a loop for each one of those visualizations. The tricky thing that with this build is that when Tableau loads up the visualization, it only has an onSuccess callback function. It does not have an onError function, which was really annoying because I was having problems with one of the other dashboards loading in tests. It was failing to load, and the whole process was getting hung up because they couldn't call anything to do. So I found on the Tableau forums, somebody was actually monitoring the messages between Tableau server and your browser, and the JavaScript API is actually communicating back and forth. And you can read those messages, and there would be a message that said something like, dashboard load completed, and you could read for that, or and when that happened, you could tell it, all right, just move on to the next one, and log the number of seconds. So that's this whole handle error message thing, and I did not really write all this stuff. Again, best practice is just to steal what somebody else wrote. Closing on that. And then this is the make table part, which is adding rows, equal tags, and pending results. So all this is on my blog if you want to reference it later. See if you can leverage it in your environment. Feel free to steal everything that I put together. So that's one great thing I think about the Tableau community is that everybody's constantly giving back. They're coming up with crazy ideas and pushing those ideas out onto their blogs or publishing Tableau public vids that you can learn from. So I encourage you, if you've learned anything from this and you take anything away from anybody else, get out there, be a part of the community. Mostly everybody's on Twitter that's in the Tableau community, so get a Twitter account, maybe put a blog. You don't think anybody will look at it, but I felt the same thing. But hey, you should create a blog or you should join Twitter. I'm like, fine, who's going to follow my stuff? But I think I've got somewhere near 800,000 blog views with them. So people are paying attention. It's a good way to get the training up there. All right. This has my reference to my blog too, if you want